We are now going to discuss the differences between waxes, fats, and oils. All three of these are considered the fatty acids group. Waxes are esters of saturated fatty acids, which remember are carboxylic acids. So they're esters of these carboxylic acids. An ester is a carbon double bonded oxygen and an oxygen between these two. You may remember from previous chapters that this process of creating an ester is done through esterification. And that's when you take the carboxylic acid of one. So if we have this here, that was originally part of the carboxylic acid. CH3, CH2, 14, C double bonded oxygen with an OH group. And then this part here was originally an alcohol. So that would be CH3, CH2, 29, OH. So all I've done is put a hydrogen here and an OH here. This OH group and this hydrogen come together to form water. And then the carbon and oxygen bond up to make the ester. That's why they say it's an ester of a fatty acid, because of this part right here. Notice the word saturated. That means these will be primarily solids at room temperature. And a long carbon alcohol, which was this. You find waxes on things like plants and fruits. We actually put them on fruits when we ship them now to hold in the moisture and to protect it from bugs and things along those lines. So some of them are made naturally. Some plants will automatically put wax on their leaves to prevent dehydration, and some of them are man-made, like the way we wax our fruits and vegetables before shipping. Triacylglycerols is another version of this. Once again, we're talking about esters. And the process of esterification where you're reacting a carboxylic acid with an alcohol to make the ester. A glycerol, notice the OL ending. That means it's an alcohol. This originally looks like CH2 with an OH group, CH with an OH group, and another CH2 with an OH group. It's three carbons linked together, each of them holding its own alcohol. That's why you find tri in front of it. Fats and oils make up the triacylglycerol group. So here's an example of a triacylglycerol. Notice here's the glycerol right here. There's originally an OH group on each and every one of these. And then on each of these carbons, there is an OH group. But those two got together to make water. And that's when the oxygen and carbon came together to form the ester. And that, once again, is called esterification. It's done it 3 times now because there's 3 alcohols on glycerol. So here's the glycerol originally, and now we put a carboxylic acid or a fatty acid on each and every one of them. So if we wanted to compare these two, they both have the esters, they both go through esterification, but the triacylglycerols have that glycerol into it where they have 3 alcohols in a row, forming 3 esters in a row. So as I said before, originally they all had OH groups. The hydrogen from each of these ended up reacting with the OH group from the alcohol to form water. Because it did 3 times, we have 3 waters. And the ester group was formed. It doesn't matter if they're the same fatty acid or if they're different. It's just the fact that there's 3 of them. Fats are typically solid at room temperature, such as meats, whole milk, butter, or cheese, whereas oils are liquid at room temperature, like olive oil or safflower oil. Think about the grocery store when you're trying to compare and contrast these. Because these are solid at room temperature, fats are typically saturated hydrocarbons, whereas oils are unsaturated. Because they're unsaturated, there's double bonds. And remember, cis is the natural version of it, which is forming kinks. Now, this is just like the introduction to fatty acids when we compared and contrast saturated and unsaturated. Because of the kinks, they don't stack up very well, which means that they're not going to be compact and they cannot interact with each other. This is giving it a very low melting point because of the lack of interaction, which is why it's a liquid at room temperature. So here's another example of it. Because of the kinks, they don't necessarily stack up the way a saturated hydrocarbon would. And that is the difference between waxes, fats, and oils.